Let's talk about another application of excision. We're gonna use excision to find the homology groups of the sphere. To be more precise, we're gonna find these homology groups of the sphere using excision, and also our first application of excision, i.e. the claim that relative homologies are just reduced homology of quotient. Now, combining this result with the long exact sequence for homology of pairs gives us the following long exact sequence. This long exact sequence will allow us to compute homology of quotients. Now, how are spheres in any way related to quotient? Well, we can actually view spheres as quotient. If we look at the pair of the n-dimensional disk and its boundary sphere, then the quotient of this pair is just gonna be the n-dimensional sphere. For example, here I've drawn the case when n is 2. When we shrink this boundary circle of the two-dimensional disk to a point, we get the two-dimensional sphere as 2. Now, replacing x with the n, a with Sn minus 1, and x over a with Sn inside this exact sequence gives us the following exact sequence. Now, since Dn is homotopy equivalent to a point, it's contractible. By the homotopy invariance axiom, we must have that these homology groups are 0. In particular, this map here must be an isomorphism. Thus, we have an isomorphism between hi of Sn and hi minus 1 of Sn minus 1. Now, by induction, we can bring this back to the case of S0. So now it remains to compute the homology groups of S0. Now, what is S0? S0 is just a 2-point set. So then we can immediately see what the homology group is in positive degree. In degree R, we can use our previous theorem on homology groups of quotients to see that this homology group is 0. Here observe that by definition of reduced homology, this homology group is isomorphic to the relative homology group of S0 relative to P. And then, by the theorem on homology of quotient, we know that this is isomorphic to the reduced homology of the quotient of S0 by P, which is just Q. For positive R, this is just 0. So we see that this homology group is trivial in positive degree. It now remains to compute H0 of S0. To do so, let's look at the long exact sequence for the pair S0, P. Observe that the quotient of S0 by P is just Q. So this is just Q. And so we have this term is 0 by the dimension axiom. And then these terms are just gonna be the coefficient group. So those are G. Moreover, we have a section here induced by the inclusion of Q into S0. Thus here we actually have a split short exact sequence. So H0 of S0 is just gonna be the direct sum of these two terms. Thus H0 of S0 is isomorphic to the direct sum of two copies of the coefficient groups. Whereas the reduced homology group in degree 0 is just gonna be isomorphic to the coefficient group. Now we can come back and compute homology groups of any n-sphere. As previously mentioned, we have established that the ith reduced homology group of the n-sphere is isomorphic to the I-n homology group of the sphere S0. In particular, if I is equal to n, then I-n is just 0, so this homology group is just going to be isomorphic to G. Otherwise, it will be trivial. Thus, the reduced homology group of the n-sphere is only non-trivial in degree n, and in that case, it's going to be isomorphic to the coefficient group.